Hello ma'am, good day. I am Perlita Lagrimora, Section PAN Organic Chemistry. This is my video oral presentation in your subject, Organic Chemistry or AG 104, Course Pack 3, Chapter 3. That contains 2 activities, Activity 5 and Activity 6. I choose 3 questions in Activity 5. So, question number 1, question number 2, and question number 3. So, let's start with question number 1. Give the name of this alkene by showing the process step by step. So, alkenes are named using a series of rules similar to those for alkanes, with the suffix E in E in place of A in E. There are 3 steps in naming this alkene. Step 1. Name the parent hydrocarbon. Find the longest carbon chain that contains the double bond and name the compound using the suffix ENE in place of A in A. Step 1. Name the parent hydrocarbon. Find the longest carbon chain that contains the double bond and name the compound using the suffix ENA place of A and E. So, this is our alkene. So, our longest carbon chain is 1, 2, 3, 4. So, 4 for butane. Step 1. The longest carbon chain is 4. Therefore, parent name is butane. Presence of double bond butene. So, the parent name, the presence of double bond is butene. So, let's proceed to step 2. Number the carbon atoms in that chain. Begin numbering at the end nearer the double bond, or if the double bond is equidistant from the 2 ends, begin at the end nearer the first branch point. This rule ensures that the double bond carbons receive the lowest possible number. So, that's why I start numbering here, because I start numbering at the end nearer the double bond. In this case, this double bond starts here, which is closer to the end of the chain. So that's why, carbon 1, carbon 2, carbon 3, and carbon 4. So we have substituent that attached to carbon 3, which is CH3 or methyl. So let's proceed to step 3. In step 3, it's time for writing the full name. Number the substituent on the main chain according to their position and list them alphabetically. Indicate the position of the double bond by giving the number of the first alkene carbon and placing the number directly before the ENE suffix. So, our step 3, our parent name is butane. So, we have substituent, which is 3-methyl. Double bond attachment is carbon 1. So, our suffix ENE for alkane. So, therefore, the name of this alkene is 3-methyl, which is our substituent, and our parent name, but, and the carbon that the double bond attached, which is 1-in. So, therefore, the parent name of this alkane is 3-methyl but-1-1-in. Okay, let's proceed to the next problem. Our question, give the name of this alkane by showing the process step by step. So, step 1, the longest carbon chain is, should count, 1, 2, 3, 4, 5, 6. So there are 5 carbons. So the longest carbon chain is 6. Therefore, the parent name is hexane. Parent name, hexane. Presence of triple bond, hexane. Because we find the name of the alkane, which is YNA. So we change ANA to INE because we find the alkane. So therefore, the parent name is this one, hexane. To step 2. So in this case, I start numbering at the end nearer the triple bond. In this case, the triple bond starts here, which is closer to the end of the chain. So, carbon 1, carbon 2, carbon 3, carbon 4, carbon 5, and carbon 6. So, we have our substituent that attached to carbon 3, which is methyl. So, our parent name is hexane and our substituent is methyl that attached to carbon 3. So, let's proceed to step 3. So, our parent name hexane, substituent 3-methyl because our substituent attached to carbon 3. And next, triple bond attachment is carbon 1. Suffix YNE for alkane. So therefore, the final name of this alkane is 3-methyl hex-1-ene. Let's move on to the next problem, which is problem number 3. Give the name of this cycloalkene by showing the process step by step. Next problem, which is problem number 3, which is cycloalkene. So, in cycloalkenes are named similarly, but because there is no chain end and begin from, we number the cycloalkane so that the double bond is between carbon 1 and carbon 2. And the first substituent has low a number as possible. How many carbons are there in this cycloalkane? So 1, 2, 3, 4, 5. So our parent name is pentane. So the step 2 is we start numbering. So I start numbering at the left side because as what I said, that the double bond is in between carbon 1 and carbon 2. So that's why I start numbering here. So carbon 1, carbon 2, carbon 3, carbon 4, and carbon 5. So let's proceed to step 3. Our parent name is pentane. Suffix ENE for alkene. Substituents carbon 3 methyl because our substituent attached to carbon 3, which is methyl. So therefore, the name of this cycloalkene is 3-methyl cyclopentane. Okay, let's move on to the next activity, which is learning activity 6. Because we're done with learning activity 5. So, in learning activity 6, there are 4 questions. So, the first question or number 1 question is distinguish between the cis and trans isomers. Okay, this is my answer in question number 1 in distinguishing cis isomers and trans isomers. So, this is the way of distinguishing cis and trans isomers. So, cis isomers are molecules having the same connectivity of atoms and are composed of identical side groups that can be found on the same side, while trans isomers are molecules having the same connectivity of atoms and are composed of identical side groups that can be found on the opposite side. So, that's all. Okay, let's proceed to question number 2. What is the reason why an alkene is not a cis trans isomer? So this is my answer. Alkenes cannot have cis-trans isomers if a carbon atom in the double bond is attached to identical groups. So this is the reason why the alkenes cannot have cis and trans isomers. Okay, let's proceed to question number 3. Give 2 examples of cis isomers alkene by showing how it is named. So at this point of time, this is my example and showing how it is named. So example number 1. So there are 2 substituents which is bromine and bromine also. So, we have only 2 carbons. So, it's either carbon 1 or carbon 2. And our substituents are on the same side. So, that's why it is cis isomer. So, di because there are 2 substituents and bromo is our substituent and the parent name is ethene. So therefore, the final name of this cis isomer is cis-1,2-dibromoethane. Proceed to our next example. So, our substituents are chlorine that attached to this carbon and another chlorine is attached to this carbon. So, either it is carbon 1 or carbon 2 because there are 2 carbons only. So, in this problem, the substituents are on the same side. So, therefore, it is cis isomer. So, therefore, the final name for this cis isomer is cis-1,2-dichloroethene. Okay, let's go to problem number 4 or question number 4. Give 2 examples of a trans isomer alkene by showing how it is named. So, this is my example number 1. So, first, we have 2 substituents which are bromine that attached to this carbon and another substituent is attached to this carbon. So, we have 2 carbons only. It's either it is carbon 1 or carbon 2. But our substituents is on opposite side. That's why it is trans isomer. So, therefore, the final name for this trans isomer is trans-1,2 because this substituent is attached to this carbon, which is we name this carbon 1 and carbon 2. So, and this other substituent is attached to this carbon. So, we write it 1-1, 2 dash Bromo because there are two bromine, so dibromoethene. So therefore, trans dash 1 comma 2 dash dibromoethene. Okay, let's proceed to another example, which is example number 2. So in this example, we have our longest carbon chain. So this is our longest carbon chain. So we number it carbon 1, carbon 2, carbon 3, and carbon 4. So our double bond is connected to carbon 2. So therefore, and we have 4 carbons, which is butane. So therefore, the final name for this example number 2, which is trans isomer, is trans dash 2 dash butane. So that would be all for my video oral presentation in naming alkenes and alkenes. Course Pack 3, Chapter 3, that contains 2 activities, Activity 5 and Activity 6. So that would be all, and I thank you.